Welcome to our session, Beyond Cool Dashboards and Fancy Visualizations, using Splunk as a full-stack development platform. So first off, thanks for taking time out of your lunch schedule to come listen to us. Hopefully we'll make it worth your while. If not, we'll hang out afterwards and you can complain to us. So forward-looking statements that Splunk requires us to put on, so I'll leave that on for 2 seconds. This is the agenda we're going to cover in the session today. So we'll first start off with a little background on our company, Qmulos. We have 2 premium Splunk apps that are focused on compliance and auditing automation. The first one is Qcompliance, and the second one is Qaudit. We'll focus on Qcompliance for today's presentation, as that is our flagship app. So what I'd like to do is walk through the features and functionality of Qcompliance, use that as sort of the context for what we consider to be a pretty rich, full-featured enterprise web application that you can use on top of Splunk. We'll walk through the architecture of that, and we'll do a deep dive into each of the subsystems and components of that architecture and talk about how we've implemented those pieces using functionality from the Splunk platform. And then we'll close it out with a comparison of some past experience where we've built a similar solution from scratch and using a combination of open source technologies. So that's the agenda. So this is us. My name's Tulu, VP of Product Development at Qmulos. 20+ years experience, commercial software development, last 10 years focused on cyber solutions for large government agencies. And this is my partner in crime, Daniel Lechev. I'll let him introduce himself.
Hi, I'm Daniel Lechev. I'm a senior software developer at Qmulos. I work on both the 2 apps. And before this, I used to work on the DoD's continuous monitoring solution, which had millions of devices.
So there's a lot of material we want to cover today, and we're probably not going to be able to get into the level of depth or detail that you're hoping to get. So there's our contact information in case you want to reach us for some follow-up questions, discussions. Okay, so first a little bit about our company. So we were founded by a gentleman named Matt Coos, who was a former executive at DHS. So he was responsible for bringing cybersecurity continuous monitoring to all of the different .gov networks. And at some point in that career, he met with the CEO of Splunk, and a light bulb clicked, and he realized that if he could be building the types of solutions he wanted to on top of Splunk, it would make things very easy and achieve the goals that he wanted to achieve. So after that meeting, he left government service to found the company. And the focus of the company is really around compliance automation to deliver actual operational security value. So the way we do that, we've got 2 apps built on top of Splunk. They are native Splunk apps, so they'll deploy into your search head, take advantage of every capability of Splunk as a full-stack platform. We've got our own data models, analytics, and visualizations built off of those. And they take advantage of the data you're ingesting into Splunk to help you effectively, or help you assess how effectively you've implemented your security controls. So I want to start with an overview of the Qcompliance workflow and functionality. It's built around the NIST risk management framework. How many in the audience are familiar with that? Okay, so I see some. It's, for those who aren't familiar, it's a simple 6-step process that we consider to be very effective for managing the risk and compliance posture of your applications. So I'll walk through these 6 steps and talk about the functionality within our application to support each of those 6 steps. So the first step, categorizing your system, you are baselining your system based on the sensitivity of the information and capabilities that it supports. So following the NIST standard, you give it a low, moderate, or high baseline based on that information. And depending on that baseline, some subset of controls apply to that system. So the higher the baseline, that means the information and sensitivity, or the information and capabilities that it processes are more sensitive, so more security controls have to be applied to that system. Right? So we have capabilities within the application to allow you to baseline your systems, and then the appropriate set of controls applied based on that. So that's step 2, right? Selecting the controls that apply based on the baselining of your system. And you can do further tailoring of the controls based on some additional unique aspects of that system. So step 3 is implementing your controls. So as you're utilizing different security tools and devices, as well as custom application code to lock down your application, you're also ingesting that log information into Splunk. And we take advantage of that log information and the events from those to help you automatically assess how effectively you've implemented each control, which is step 4 of the RMF process. And the way we support that is through a set of dashboards for all of the controls and enhancements from the NIST 800-53 Security Control Catalog. How many in the audience are familiar with that? Okay, so some are, some aren't. So it's what we would consider probably the world's most comprehensive security control catalog. It covers all of the typical things you would consider: access control, authentication, vulnerability scanning, configuration management, as well as physical security controls, organizational security controls, and training, and so forth. So probably the world's most comprehensive security control library out there. So that's why we've built on top of that as the standard. So step 4 is a set of dashboards around those controls from NIST to help you automatically assess effectiveness. And step 5 within the RMF process is based on how effectively you've implemented those controls. You make a decision as to whether or not that system should go online into your production networks. So to support that, we have capabilities and screens that score your systems based on control compliance, and the decision maker can use that to make a decision as to whether or not the system should be authorized to go live on your production networks. So once it's gone live, step 6 is continuously monitoring that, right? So as a system goes into production, there's always configuration drift and other changes that may alter its security or compliance posture. So you need to continuously monitor that system in production to make sure that that compliance posture is maintained. So we support that with some capabilities and dashboards to allow you to continuously monitor the effectiveness of your controls. So that is a quick overview of the functionality of Q compliance. So this is the architecture for how we've implemented Q compliance. We also think it serves as a good reference architecture to build other similar web applications that are similar in level of complexity and functionality on top of Splunk. So user interface layer, talking to a business logic layer through APIs and web services. Within the business logic layer, there's user and machine workflow, state management, data access capabilities. The data access components allow us access to 2 data stores that we utilize. So a transactional data store for more write-focused capabilities, and then an analytical data store for the analytics and more read-focused capabilities. Then cutting across all of those layers, application security, authentication, access control. So what we'd like to do next for the next several slides is walk through each of these subsystems, give a little bit of an overview on the capabilities and requirements from the perspective of our application, and talk about how we've implemented each of those using Splunk. And then we'll do a deep dive into a particularly interesting example or scenario that we encountered while trying to implement those things within Splunk. So with that, I'll hand it over to Daniel to take you through the different subsystems and components.
So our app needed a way to get all the compliance data into the app. So we have forms that get the compliance data. We have custom input elements that we had to use to visualize organizational hierarchical structures and a way to select different organizations. And then we had control dashboards that would change depending on what control you choose. So the way you end up doing that in Splunk is using a whole bunch of JavaScript and then putting HTML sections into your XML pages, and then relying on the Splunk web framework to dynamically add things as you go along. So for example, we have a framework page that displays dynamically different scoring categories depending on the framework that you're looking at. So in this scenario, I basically have all those three components that we just talked about. We have the input on the top left, that's just a button. You click it, you then select your organization based on the hierarchy, and it selects it for you. Then once that's selected, that then triggers all those scoring categories to populate depending on what system you've selected. So those don't exist initially on the page, but they're added once you select the system. And then the last two, the bar chart and the table, they're just running off the tokens once you select the scoring category. So once you select the scoring category, you change the titles and you change the information. So the three ways we did this is for the input, you put an HTML section inside the field set, and then we use an HTML template to replace that with the button that we needed and the dialog that went along with it to actually show that stuff. For the scoring categories, we used the Splunk web framework where we have single charts that you can create and add dynamically, and then you can also add post-process searches, so anything that works off a base search as a way of adding that after the fact. And the final piece was just setting the tokens directly in the JavaScript and using those tokens as part of the titles and then the data coming from the scoring categories. As far as APIs and web services, we needed a way to ingest, upload some files when it comes to policies. We needed a way to return compliance data and ingest compliance data, and we need to be able to talk to other apps. So the way we implemented that in Splunk is we actually use two different ways that are out there. One is cherry pie controllers, and then the other one is custom REST endpoints. So they're similar in that the fact that they both use Python to create the web service, and they both use the web.conf to expose it. But the main differences between one and the other is that the routing in the cherry pie controller is more of what methods do you have versus the REST endpoint where you can have handlers for your get, post, delete, put, and route different parts of the path to your controller. The pros that we found while using the cherry pie controller is that you can actually return data in almost every format, just like a regular HTTP request. The con, though, is that you didn't have access to anything else other than the current user session key. So that doesn't allow you to return anything else that they wouldn't already see in a search. So that's why we also made some custom REST endpoints. The plus on that one is that you have the ability to get a system authentication. So you can actually return data that the user doesn't directly have access to, but they can still access to the web service. And the other plus of that was we can actually use that web service as part of a REST command inside the search. So you can actually boil down a whole bunch of simple XML queries into that particular endpoint. So let's move to the next thing. As part of the app, as Tu was talking about, we went through the RMF process. And to go through the RMF process, you need to have user and machine workflow going through the whole thing. So we had to basically use custom drill downs as a way to move users through different subflows on different dashboards. We use tokens, whether it would be you click a token and change the visual, or you click it, you pass the token down in the URL to another dashboard so you can keep state. And we also use custom alert actions. And there's this one particular example we'll go over here. So we, as a way to automate the self-assessment process and merge the user and machine workflow, we used this particular design, the custom alert action. So what we did was, whenever a user would navigate to a particular page and they've already selected a system, we'll pass that system and control data in the form of cookies to the alert itself. So if you actually have ever worked with custom alerts, it's pretty straightforward, where you have just a HTML file and then you'd have declarations in the conf files. But what we needed was a way to pre-select the different values that we wanted. So not only we get the searches and the drop-downs, but pre-select those values. So we had to have a workaround where we had an iframe inside the HTML so we can load our JavaScript so we can actually use the cookies. Because as you know, there's some restrictions on what you can actually put in these files that Splunk hosts. The next thing that was part of that we had to keep track of was state management. So since we have all these compliance data that changes over time, you have the organizations can change, the systems can change. You need to keep track of that. So we used Qmulos for that purpose. And then at the same time, you need to keep track of, as I said before, what is the user looking at? So to keep that across the site is, I will go further dive into how we did the JavaScript cookie design. So in this case, most of our pages, along with the org selector, actually have JavaScript cookie code where they save the particular token for that system into the cookie, and then whenever you navigate to a new page, we pre-select that token on the button, and at the same time, we set it as a token so you can use it in the visual. So that way, when the user is going to the website and going to the workflow, they have the system selected across the website, and they're seeing the visuals that's important to them. As far as data access, initially we just needed the raw data, just the logs. How can we use this as evidence? But at the same time, once we started using the KV source more extensively, we needed the capabilities to create, read, update, and delete different objects. So that kind of brought us to the 3 different ways you can do it on Splunk, which is you can do it directly through the SPL searches. You can do it through the JavaScript AJAX calls that you use the Splunk REST endpoints, or you can do it through the web services themselves using the Python SDK. So as our app evolved, we went through each one of these. So initially, it was just pure dashboards. How do you get the data out? So that was just a regular SPL search, easy to create, easy to update in the XML, but it doesn't really give you any update capabilities. So if you're working with KV stores, the only way you can update is using output lookup. So that's when we went to using the REST endpoints that are available to you in the JavaScript to do direct CRUD operations. But then that helps you do all these operations, but at the same time, it then complicates the code where you have to actually now have JavaScript files that go along with all information. So your PS guys can necessarily see what's going on directly in the XML, and they have to have some JavaScript knowledge. And then the final part of that was we then moved off one further step where you even separate the entire the KV source directly from the interface and just move into the web services. So it was a way of data layer separation, and as I said before, working with other apps, you need the web services as a way to connect all of these. But again, that requires you to now have a web service, so you now have to move all your data access to web service. But the plus is You can now just have a REST call search or do any of these things straightforward. The one thing that's probably different than most Splunk apps that we do is using the KV store as a relational database. So instead of just using it for a lookup, if you have this key, what is the value coming out? We actually use it as a way to, like I said before, store our RMF data as we go into the app. It stores the key entities, and it also allowed us to have different environments set up for our customers, because now they can customize what they're seeing based on what they have in their KV stores. So on Splunk, you just create the KV stores, but it became much more than that, because now when you treat it as a database, you have to do all these operations to maintain it as you're going across. So these are three of the different scenarios we kind of ran into when we were working with these. So one was, creating them, which is straightforward. Make it the .conf changes, put it in the transforms. But then you have to also integrate the user interface to actually make the data, input the data directly. And then you also have to have the ability to populate the data at the initial load of what is the data that every environment needs to have. So we had to have CSV lookups and just do safe searches to pre-populate all this data. Then once you have some, as just you would do with a regular relational database, you can have schema changes. So in this particular example, we need to add the next assessment date for a control. So the way you end up doing that is you change the schema, but then it comes into how do you, adding into the user interface, and then how do you actually move data that already exists on KV source on the customers right now and moving that on to the current format. So you now have to have a data migration script coming in. And then the final scenario that becomes interesting is these structures have relationships. That's the whole point of a relational database. So if I'm deleting a system, why should I care about its compliance data at that point? If the system is not applicable anymore. So now you, again, change the user interface, but then you got to think about purging all data that's now stale, so the environments don't have any old data that it's not important to them anymore. And then on the other side, why do you build it on Splunk in the first place? Is because you have all the analytics there for you. You have the events, you have the data models. How to use that to help you accomplish your goals. So we used acceleration for the visuals. We used the SIM as a way to get data into the evidence that we need. And the way we did that is by extending the SIM data models and making our own data models. So how do you make your own data models? You basically have to keep track of, have a use case in mind for those models, and what kind of data you're expecting to come in, what data is coming out. Because once you create them, any change that you make has a ripple effect to whoever's already using this. So if you have customizations that were made on the app on a customer's environment, now those queries might not work anymore, or the data that's coming in is not what you expect. So as a tip, when you're making your own data models, we say you should try to use something similar to SIM or something close to it, because all of the Splunk DAs that are out there on Splunkbase are already using it anyways. So how do you shorten the amount of time that you get the data that you need in your data models is by already using the stuff that's already out there. And then the final piece that goes across the entire app is the access control. So in our app, we have two types of access control. You have capability access control, so what can the user do? And then we have data access control, is what can the user see from the data that we have for them. So the way we implemented this on Splunk is we took advantage of the native RBAC capabilities, such as authorize.conf, default.meta, but then we also had to do our own, like I said, web services, so we can kind of filter the data out ourselves, and we had to hide elements ourselves so they don't have access to them in the first place. So we took a layered approach where we had different strategies that we use at each layer. So the user interface, we use the default.meta to just stop users from accessing particular pages. We then also used the REST calls you can use through Splunk to actually get the user's roles and permissions, and use that along with JavaScript and CSS to hide different elements and pages that they do see that they shouldn't have access to. Then the second piece is how do you actually make that stick is you use the web services to filter the data coming back in the first place and making sure that you check users' access before they try to access something they shouldn't be seeing. And then the final piece is locking down the actual data so people can't just search around what you're trying to do when you're restricting the data. So one is you use the default meta again to basically lock down all KV stores to the admin users only, so no one else can write or read. And then using the index role permissions as a way of not allowing users to see any raw events that they shouldn't have access to. So now I'll hand it off back to Tu and talk about the challenges that we've seen when we're implementing on different environments. Okay.
Thanks, Daniel. So hopefully that's given you an overview of how to implement that reference architecture that we presented earlier on top of Splunk. So we've really only scratched the surface into each of the subsystems and components. I mean, it probably would have taken one session per subsystem to really get into the level of details that we'd love to share. But hopefully this gives you enough of an understanding and where to start from when you're trying to implement a similar architecture on top of Splunk. So as we mentioned in the introduction, Daniel and I have some experience building a similar solution for a government agency, so continuously monitoring close to 2 million assets across the government's networks, looking at vulnerability scanning information, configuration scannings, AV, and so forth. This was all built from scratch, initially implemented in a .NET stack with a SQL Server backend. And then as the footprint grew, as adoption grew, we started running into scalability challenges. So it was migrated to a Java and Hadoop-based stack later on. All of the charts, graphs, tables, visualizations were custom implemented using a variety of .NET controls, open source JavaScript libraries, and so forth. So the key thing from that experience was that we spent a lot of time on the data engineering aspects of the solution. So data integration, working with different APIs from data sources that we need to pull that data in from, a lot of ETL, extract, transformation load, data mapping type capabilities. So a lot of effort was spent on that rather than the actual business logic and analytics of a continuous monitoring solution. And scalability was always a challenge. So in the end, we built the solution, it was deployed, it's adopted, but the takeaway was that it took more time and resources than we've spent on Q compliance, and we still had less functionality. So that's kind of a high-level overview of the experience with building a similar solution from scratch. And if you want more details, I wrote a case study about this in ISACA Journal. There's a link to it. It should still be available on the website, so you can check it out there. So based on that comparison with building from scratch open source versus using Splunk, the key takeaways. So building on Splunk is a tremendous productivity enhancer versus trying to build this solution from scratch. As I mentioned, when you're building the capabilities from scratch, you're going to spend a lot of your time and energy on the data engineering, data plumbing aspects versus focusing on the analytics and the business logic of whatever domain your app is focused on. The thing to keep in mind, though, is that basic dashboards and queries embedded in all of your simple XML dashboards will only take you so far, right? That's great for building an initial proof of concept type application, but it's going to evolve. So do some upfront design and have kind of a target architecture in mind And as you kind of progress through your development life cycle, each subsequent sprint or release should take you closer to that target architecture. And that's kind of how our application evolved, although I think initially there wasn't kind of a really well-defined target architecture in mind, which is another reason why we wanted to present kind of this reference architecture as something that you can leverage as a target architecture. Apply common web architectures that you see out there. A lot of the common web architectures, such as model view controller, CQRS, for those who aren't familiar with that, command query responsibility segregation. That's kind of what inspired our design to have separate transactional data store and separate analytical data store. Right? So one is more focused on write capabilities. The other is more focused on your analytical queries. So we took some principles from there. And then as Daniel mentioned, as we evolved, the need to have a separate services layer to separate UI functionality from data access functionality. So we needed to start moving to more of a services-based architecture as well. That also gave us the ability to do more fine-grained data access, especially with the KV store data. Right? So we needed a way to filter out what data from a single KV store that a user could access based on what organizations and systems they own or operate. So building that through custom web services allowed us to do that. So all of that filtering logic was built into those web services. So just have some of those common web architectures in mind, and that, as we've proven, can definitely be implemented on top of Splunk. So key takeaway, building on Splunk is going to make your life a lot easier, tremendous productivity enhancer. You can build it from scratch, but there's going to be a lot of pain, a lot of resources spent on data integration, data plumbing, and less focus on the actual use cases that your app needs to support. So with that, here are links to the key resources grouped by the different subsystems of the architecture we've presented. These slides will be available later on as well, so you'll be able to get the links from the slides there as well. So with that, I guess we'll open up for Q&A.
More?
Yeah. Pardon? Right.
No.
Yeah, it's all completely within the Splunk ecosystem, Splunk architecture. Right. Yeah. Chose to keep it within Splunk rather than, yeah. So there are reasons for that. One of the primary reasons, so a lot of our target customers are government, and in the government space, when you tack on an additional component, an additional server, that changes the whole attack surface of the application. It has to go through the whole certification and accreditation process again. So if you can keep everything within a single stack, that makes it a lot easier for us to get. Yeah. Exactly. Yep. Yeah. Yes, sir.
With that thought, can you, to me, it would have been a little easier, and this is my thoughts, with a relational database like Oracle, maybe provide all that with your Docker container, and then you wouldn't have to revisit the security issues you might have on the government side, right?
Yeah, I mean, there's always other,
Yeah.
yeah,
I'm no means of saying
sure.
anything wrong, I'm just brainstorming out
Yeah,
a little bit with that was the one piece that I'm just trying to understand a little better with the KV as opposed to
like a
lightweight.
database, yeah. So we actually, I mean, using the KV store as a transactional data store, there wasn't a lot of pain. It actually fit pretty nicely, right? So I mean, KV store in the back end is a MongoDB, right? So we didn't, sort of the challenges that Daniel mentioned with using that as a transactional data store, it's the same types of challenges you would have with any sort of database, right? Having a well-defined schema, and once you're out into production, if you need to make changes, you have to take into consideration backwards compatibility. It's anytime you've got a full-blown database in your system, all of those issues apply, right? All right, go ahead.
And then the other thing is you don't have to worry about doing a single sign-on solution so you can authenticate to your Oracle database and the Splunk. You can just do it directly. And then the second piece was we use parts of the KV store, like the KV store database, actually in Splunk directly. So like even though we use them as like the entities, we also use them as lookups as well. Because there was piece of, like, for example, when you add the assets and say, what is your assets, like in terms of IPs, we still need that list as a way in Splunk to actually filter data down for those particular reason.
Makes it more lightweight for you.
Yeah. Yes?
Yes.
First and foremost, I would like to thank you. This is the best presentation that I've seen in the entire.
Oh, thanks.
Thank you.
We're humbled.
I have a couple of questions. One is time and how long it took you to build regular, development as opposed to working in the Splunk framework. And the second one is why you guys didn't use things in SQL like Microsoft data transformation services or reporting services. It was not feasible for your particular situation or?
Yeah. So let's answer the second part of your question first. So actually, the system that we built prior to this did use those capabilities, Microsoft SSRS, SSAS, all of its ETL and analytics capabilities. And we hit a lot of scalability and performance challenges once we hit a certain number of assets that we're trying to monitor.
Yeah, because you have to prioritize throughput of data coming in versus speed of things coming out. So I feel like Splunk is good about allowing you to put almost anything into the Splunk database and then using those data models that you can create, just like you would the SSRS, to actually display things faster. So it still has the same capabilities, but yeah, the number one thing was we would run into key issues. So if you're using keys on like a relational database, at some point you run into the problem of it takes too long to actually write something to it in the first place.
Yeah. And then the first part of your question, how long? So the initial version of the app, as we mentioned, it evolved through the different stages that we talked about, right? Kind of your traditional Splunk app, simple XML dashboards, all of the queries in that. That was built fairly quickly. It took us probably, and we're still in the process of refactoring it to this architecture that we presented to you. And we've been working on that for close to 2 years, kind of to refactor it to this reference architecture that we've presented. So that's why the point I made earlier, have a target architecture in mind and kind of have your dev process so that you build gradually towards that versus having to do a lot of refactoring to get to that target. Yeah.
Do you guys have any plans to build out for the announced Splunk Developer Cloud?
Yeah, so we've had some conversations with Splunk about that, and it definitely is something that's intriguing and that we want to build out. It's really, it's a matter of resources and prioritization. A lot of our customers still use Splunk on-prem, right? So until the business case is there, we've got a strong customer that really wants to use Splunk in the cloud. We're going to wait until that is there to kind of prioritize the investment there. So, yeah.
You're using KV store for transactions, right? Do you have any limits on the transactions? Because KV store lives on such like not indexes, like indexes, supposed to indexes. So you're limited on what you have on searching, right? So have you had cases where you hit some limits?
Like some of the default limit settings on that?
Yeah, like the number of transactions that you
Yeah, so that's interesting you say that, because one of the things that we found out when we're working with like the web services or the endpoints that they have, where you can just batch save a whole bunch of things at the same time on the KV stores, there's a limit of like 100 or a loop mark. It's almost, I think it's based on even the data size itself. So we have to like tailor the way we write data in a truly transactional world, where it's either smaller transactions, so we don't have reached the limits of how much data is going in, and at the same time, the way we structure the relationships, that's why we use the entities, like how do I explain it? I guess we were using the star structure, where you have KV stores that hold the actual entities, and then you have KV stores that describe their relationships. So you don't have any like super heavy normalized giant list of all the data.
So we've got some denormalized tables.
Yeah.
So even within the KV store, we've got kind of some different schemas that we've got some pages that kind of need everything together, right? So we've got sort of some denormalized tables that drives those dashboards to kind of speed things up.
just trying to gauge how much data that you can put in the KV store, like because you're using that as a data store, right? So
Yeah.
like what is the size of the data that you're able to put in the KV store and use it as a transactional database?
We haven't run into any limits yet. I mean, we've had to. So there's a couple perspectives to that question, right? There's how much you can send in from a throughput perspective through the different interfaces that is provided through Splunk, and there are settings you can tweak on that through their APIs, through their web services. Some of the default limits we've had to up a bit. So that's kind of throughput coming into the interfaces. As far as how much it can store, I think, so MongoDB itself is pretty scalable, right? So storage of the data itself, we haven't run into any limits from that perspective. But we've had to up some of the limits on some of the default commands, some of the APIs that come in. We've hit some of them, 5,000, 10,000. We've had to up those a little bit. So.
And also you mentioned that using the Splunk as a whole, I mean, you have no other database, right? So
Yep.
what are the retention periods that you have right now? So do you retain the data for long periods, or is it just short at some level there?
So it varies from customer to customer, right? So we don't host the application for a particular customer. So the way the application is built and sold is it's deployed on-prem into each customer's environment, and then we tweak retention periods and whatnot based on the specifics of that environment.
Yeah.
Okay.
I noticed your app seemed to be geared toward ISP 153. How difficult is it, or what does it take to get to the newer controls, the 800, 170, and where we're going next?
Right. So good question. So we've actually, as part of our refactoring, we've refactored. So initially it was built very tightly coupled to 800-53, and we've refactored the architecture so that we can now support any other control library standard. So we call it our dynamic control architecture, because as we're expanding into commercial sector, commercial sector, private sector, we're finding a lot of customers don't necessarily use NIST. They've got other control standards. So we've refactored to support that.
Yeah, like PCI, ISO, GDPR, all those.
This gentleman had a question.
What's the typical size of every customer? How many searches?
So it's a pretty wide range. We've got some very small deployments where they've got everything running on a single instance. And we've got some that are deployed in a very large search head cluster. So yeah, the way that the app is built, it can kind of support any of those deployment footprints.
Yeah.
Okay. I see. Can't see the number.
I
But,
think it's red. It's they're kicking us
okay.
out because it's
Okay.
10 o'clock.
But
I mean,
we-
not like 1 o'clock.
we can hang out outside.
Outside, yeah.